Hello everyone. Today we're going to start chapter 3, differentiation. In chapter 2, we discussed the definition of derivative. But in many cases, it will not be convenient to use the definition directly to find the derivative functions. So instead, we're going to summarize some basic rules of differentiation in section 1. And then we can use those rules later when we take the derivatives of functions. And there are 4 basic rules in this section. Before I introduce those rules, let me just talk about other notations for the derivative function. We can use f prime as we did before for the derivative of function f. But we can also use dy over dx, or df of dx, or y prime, or even capital D sub x f. And they all mean the derivative of the function f. So in this section, we're going to use the d over dx notation. The first rule says the derivative of any constant or constant function c is 0. For example, the derivative of 28 is 0 because 28 is a constant. Rule 2. The derivative of the power function x to the n is equal to n times x to the n minus 1. So you just multiply the exponent and subtract 1 from the exponent to get the derivative of the power function. Remember, the power function has a constant exponent n, and that can be any real number. It can be integers, it can be decimals, it can be even radicals. So, for example, if we want to find the derivative of x itself, and then we rewrite the x as x to the 1, so we can use the power rule to get 1 times x to the 1 minus 1, which is x to the 0, which is 1. So the derivative of x itself is 1. Another example is the derivative of 1 over x cubed root. So this is a power function, but we need to rewrite the function in the exponential form. So we get the 1 over x to the 1/3, and then we write it as x to the negative 1/3. And then we can use the power rule to get negative 1/3 times x to the negative 1/3 minus 1, which is negative 4/3. So the final answer is negative 1/3 times x to the negative 4/3. The third rule is constant multiple rule. It says the derivative of c times fx is equal to c times derivative of f. So you can take out any constant c from inside when you take the derivative. For example, the derivative of 5x cubed is just 5 times derivative of x cubed. Then we can use the power rule for the x cubed. We get a 3 times x to the negative 3 minus 1. So we got the 5 times 3, which is 15 times x squared. The last rule is the sum or difference of functions. So if you take the derivative of sum or difference of 2 functions or even more functions, you can just take the derivative of each function individually and add them or subtract them. For example, the derivative of t squared over 5 plus 5 over t cubed is equal to the derivative of t squared over 5 plus the derivative of 5 over t cubed. We use the power rule for each part. We can take out 1 over 5 from the first part to get the 1 over 5 times derivative of t squared, which is 2t, plus 5 times the derivative of 1 over t cubed, which is t to the negative 3. And then we get 2 over 5t minus 15t to the negative 4. All right. Let me just conclude this section by the application problem. In this example, we need to find the slope of tangent line to the graph of f equals 2x plus 1 or square root of x at point 1, 3 on the curve. Remember, the slope of tangent line is just the derivative from the definition of the derivative function. So we need to take the derivative of the function first. As before, we can rewrite the function as 2x plus x to the negative 1/2 in exponent, because we got 1 over square root of x, so it's negative 1/2 the exponent, and then we can use the power rule to get the derivative of the function to be 2 minus 1/2 x to the negative 3/2, and we write it back in the radical form. Since we want to evaluate this derivative at the point of 1, 3. So that becomes 2 minus 1 over 2 square root of x cubed. So at the point 1, 3, the derivative of f is just f prime 1. So plugging 1 for x in the derivative. So we get 2 minus 1 over 2 times 1 cubed. So that's just 2 minus half, which is 3/2. And then we can use the point and slope form to write down the equation of tangent line to the graph. So y minus 3 equals 3/2 times x minus 1. If you simplify this equation, you're going to get the y equal to 3/2 x plus 3/2. So that's the answer. We're going to do 3.2 next time.